Oh, hello there. Alright, so I got this shirt from one of my students. Shout out. Pretty cool, right? I hope you guys can see it. Alright, so what I wanted to do today is I just want to do our statistics 2, linear regressions, and I just pulled up a calculator emulator. So I'm going to go ahead and just talk through all the questions and make sure you guys understand what a linear regression is. So a linear regression is a linear equation that you create, and typically it's through a calculator or computer. So a linear regression is a linear equation you create to model your data. What type of data are we going to look at in this video? I'm going to look at some heights of you guys and your wingspan, if I could find the sheet, but I will just go from the top of my head. Alright, so let's go ahead and start. So in this data, what type of data are we looking at in this video? Height and wingspan. So I'm going to go ahead and go do this. Alright, so what will data always be linear? Just thinking about it, I mean, sometimes you could do things like bacteria, right? Bacteria is the type of data that you could take just constantly looking at like a petri dish, and you look at it and you go, oh, okay, there's 2 bacteria, 4 bacteria, 8 bacteria, 16 bacteria, and you can do that with a microscope. So data won't always be linear, but sometimes you know, you will find ones that are linear. That's why you have to test it with different ones, but that's not something you want to do in Algebra 1. You know, as we move on to Algebra 2, geometry, we'll get there. Okay, so let me go ahead and put in some datas here. So I'm going to say maybe this person's 63 inches, 68, 65, 64, 66, 69, and 70, and I'll have a 6-footer in there, 72. Okay, now I'm going to fill in their wingspan. I'm going to do 60, 65, 61, 64, 64, 68, and 69, and 70. Alright, so I've entered those values in. I'm going to go back to menu, and actually in this type it's a little different from our calculator. So I can actually go ahead and graph. Can change the settings, scatter plot, looks good, exit. I'm gonna go ahead and create that. So here's my scatter plot. I'm gonna go ahead and create a regression. So I'm gonna calculate a x, which is a linear regression, because it's just x, because that's standard linear. And here it is. My a is 1.08, and I typically just do 3 digits, 1.08. You could do 1.09 if you wanted to round to 7 over here. My b is negative 7.84, and if you want to round, that could be 8.85. Okay. And if we want to write the linear equation, it's gonna be y equals a, which is 1.09 x plus b, and then the b is negative 0.785. So that would be the second part of our equation. What is the r value? The r value is 0.936, which means that it's not bad. It's pretty good, a good linear model. R squared is a 0.87, which means it has 87% accuracy modeling, right? Like your line will give you 87% accuracy as to like the real life situation. Okay, so what does R stand for? R stands for residual, and it really just means what is the distance from the point to the line. And if you have a really good R that's close to 1, that's good. So this one, like, the points aren't too far away from the line, which is a good thing. Okay, R squared do, what does R squared do? R squared is the accuracy, and you basically take your R and you square it. That's your accuracy, right? Take the percentage. How does an extreme/outlier affect the R value and linear regression? So let's just go ahead and see what that would look like. I'm gonna put this in. I'm gonna put an extra here. I'm gonna put somebody who's really tall, like 72. That would be 6 feet. And I'm gonna say that they have a wingspan of about 40. Let's say they like lost an arm or something. Okay. Now let's go ahead and graph that. See how it kind of just drops off there. Now if I calculate and do the regression, see how the R value changed to negative 0.14? That's a really bad R value. So having that bad R value means that, oh, this is not a good model. And you'll see when you draw it. Does that look really linear at all anymore? No, because this outlier, this guy who was 6 feet tall and has a wingspan of 40 inches, which is like 3 feet, it's like he had like one arm or something and he lost the other. So that guy throws off our data. Okay. What's the last example that I'll do? I'm gonna go ahead and kind of like skip that. I'm gonna say let's do height and basketball points. I'm just gonna go ahead and delete all this. Alright, so I'm gonna do height and basketball as my next one. So I'm gonna do height and basketball points. So I'm gonna have a couple people who are like 56 inches, 57, 59, 60, and I'll make it a 5-player team. I got a guy who's 62 inches, and the points they scored is something like I'm gonna say the shorter person scores something like 3 points, the next person scores something like 5, 11, 12, and 13. Okay, I'm gonna go ahead and graph it, and you can see it's kind of linear. I put a regression on it. The R value is 0.95. So the taller you get, the better you score. So what does the last example show about how real life data? Sorry, I kind of screwed up the grammar here. It just shows that you can put a linear equation for almost anything, and it might not always be linear, because if you think about it, maybe there's a capping point for this. This is like an elementary school team. You have shorter people are going to make more points. Alright, so for the rest of these, I want you to calculate the R squared values for these. So R is going to be 0.60, R squared is going to be 0.60 squared, so that would be 0.36. 0.36 is a 36% accuracy. Is that good or bad? That's obviously bad. Okay. On the back, what you're going to do is you're going to say if it's positive, negative, no correlation, or not enough information. If you look at this one, is it going positively or negatively? It's clearly going positively, so it's positive. For this one, go ahead and look at that one. What does it look like? No correlation, positive, negative correlation. You can't really say that you're going to draw a line there and it represents the data, right? It's kind of all over the place. And do that with the last one. And that is it for Chan Academy. Just do the back. This should be a pretty easy 15-minute assignment. I'll see you guys in class. We're going to do one more regression, then we're going to review, and then we'll take like a test. And I maybe wanted to throw in one more thing before the final, but we'll see how that goes. Okay. All right.